Stoichiometry is what sounds like a really complex and scary word, is really just using balanced chemical reactions and their mole ratios that are within them to do some calculations. The supporting topics that you'll want to be familiar with are the introductions to moles, balancing chemical reactions, and calculations with molar masses. The thing about a balanced chemical reaction is it's a secret unit conversion. It's really a secret recipe. So let's start by looking at this sandwich. And you can see here that we have one sandwich, right? One sandwich. And in that sandwich, we have some turkey, and we have some cheese, and we have some slice of tomato, and some lettuce, and some bread. And we can think about this as a ratio between the sandwich and the parts of the sandwich. So I see 3 slices of turkey there. Or I could also say that the one sandwich was equal to 2 slices of bread. I could also say that 2 slices of bread, in reference to this particular sandwich, was equal to 1 slice of tomato. Okay, so I won't kill this sandwich here or talk it to death. But each of these relationships that we've just talked about is a unit conversion that allows us to convert between one part to another part. So in a balanced chemical reaction, we have our reactants. Let's say, for instance, I had one black molecule reacting with, excuse me, that's a black atom, reacting with a blue molecule, and I made black and blue. Ha ha, it's kind of like a bruise. Okay, get rid of this because it should be blue. I'm so enamored with my joke that I forgot. And let's say make 2 of these molecules, which means I need 2 of these for the whole thing to be balanced. We can think about this balanced chemical reaction as a recipe. For every 2 black atoms, I make 2 black and blue molecules. For every 2 black atoms, I need 1 blue molecule, and so on and so forth. So I can relate this to this, I can relate this to this, and I can relate these 2 guys to each other. Okay, so let's say we had 4A reacting with 6B to make A4B6. How many moles of product are produced when 17 moles of B are reacted? Well, when we look at this balanced chemical reaction, we notice that there are 6B for every 1 mole of product. So that's a relationship. 6 moles of B are equal to 1 mole of A4B6. Now I can't just make this up. I have to reference a particular chemical reaction, and I have to reference the particular coefficients. Oops, it looks like I'm pointing into empty space there. I have to mention the particular coefficients that are present in that chemical reaction to get these mole-to-mole relationships. So now, I know I'm starting with 17 moles of B. If I want to figure out how many moles of product I'm making, I take my relationship from the balanced chemical reaction that there are 6 moles of B for every 1 mole of A4B6, and then I do some math. So it's essentially 17 divided by 6, which gives me 2.8 moles of A4B6 would be produced. I can use other relationships. In the second problem, I'm starting with 0.0380 moles of A, and I want to know how many moles of B I would need. Well, to do that relationship, I need to look at how many A I have for how many B. And I see I have 4 moles of A for 6 moles of B. So 0.0380 times 6 divided by 4 gives me 0.0 0.57 moles of B would be needed to react with that number of moles of A. This is relevant to you. You may not think so, but it actually is. And here's an example of why. When your stomach gets upset and produces too much acid, you might take an antacid, and often those antacids contain magnesium hydroxide. So we can talk about how much magnesium hydroxide and how much HCl we would need in order to neutralize each other in this reaction by doing some calculations using the information that we just talked about. In this problem, I'm starting with 350 moles of magnesium hydroxide. Now, it's not like you can measure your own stomach acid, but this does apply beyond just this class. So I've got 350 moles of MgOH2, and I want to know how many moles of HCl are going to be consumed if, whoa, that's an enormous amount of magnesium hydroxide. We should have made that 3.50 moles or 0.35 moles. Well, we'll end up with a really big number here. So I have 350 moles of magnesium hydroxide. I look up here and see there's 1 mole of magnesium hydroxide for every 2 moles of hydrochloric acid. So 1 mole of MgOH2 goes on the bottom, and 2 moles of HCl goes on the top, which is 700 moles of HCl, which is way, way more than your stomach is going to be making.